Hello and good day to all the panels that will be watching this presentation, Encik Muhammad Syahar and Encik Zainal Abidin. Hope you all have a good day today. So without further ado, I will start my FYP presentation. So my presentation today will be about simulation, analysis, testing, verify, and assembly of braking mechanism system of Formula SAE 2022. So this is the project summary for this FYP. So this project requires the student to design, simulate, analyze, test, fabricate, and verify braking system mechanism of Formula SAE 2022 for the UITM Motorsports team. So most of the components here are the standard parts which can be obtained from stores and data sheets from manufacturers. So other parts have to be customly designed to meet the criteria based on the guidelines and also the geometry and materials of the design. So theoretical calculations were also made to ensure the reliability and safety of the designs. And the long-term aim for this project is to design a braking mechanism system of Formula SAE that follows the rules and regulation and also improving the existing design of Formula SAE. Moving on is we will introduce the background of this project. We will start with Formula SAE. So this is the design. Formula SAE is the design competition organized by Society of Automotive Engineers SAE from the United States, which is solely for students at the varsity level for all universities across the globe. So the purpose of the design is for the students to design, manufacture, and race their Formula style race car and at a scale design to be sold or marketed to daily autocross enthusiasts. So parameters that will be evaluated in this competition is the design, cost, and the on-site reliability on the on-site presentation, which to examine the capabilities of the design. So moving on, we will explain how the braking system for normal Formula SAE car. So for the Formula race car, the braking system activates when the brake pedal is pushed by the driver. So the pedal will transfer the force to a master cylinder, which will push the incompressible fluid in the cylinders to build up pressure. So the pressurized brake fuel in the master cylinder will flow through the brake lines to the brake calipers, which in turn also be activated by the pressurized brake fuel to push the piston of the brake calipers to clamp the rotating brake rotor. So the friction caused by these two components will decelerate the brake rotor through the heat generated and put the vehicle to a stop. So that's how basically the braking system for Formula SAE car is. So moving on, we will discuss about the literature review, supporting journals that are selected and inspired this FYP. So firstly, we will discuss regarding the pedal brake ratio, which is to give the mechanical advantage for the driver input force. So pedal ratio is defined as the ratio of the amount of force acting on both master cylinders divided by the input force from the driver. So this means that the higher the ratio is, the less input force is needed to meet the required amount of force for braking. So the pedal ratio that has been chosen for this FYP is 5 to 1, which is similar to other journals like Goshikwa and Shitlin in their findings. However, there are also other pedal ratios from other journals ranging from 1.66 to 2.5, such as Mora, Patel, and Duff. So the selection of the ratio is entirely up to the geometry of the design and how much force you want to have in your system. It also needs to be balanced with the cost, operability, and reliability of the design. Moving on is the master cylinder. So the chosen standard part for this one is Tilton 7A series master cylinder. So the diameter that will be used for this master cylinder is a 1-inch piston size diameter. We'll also be using dot 4 brake fluids, which is a high performance braking fluid that can sustain higher range temperature for higher efficiency and higher performance. So we'll also be putting a bias bar. So the force function of this bias bar is to distribute the force accordingly to the brake force distribution. Since generally engine of a Formula SAE car is situated at the back, so less force is needed at the back and more force is needed at the front. So this will be adjusted through the bias bar. And moving on, there is the brake calipers. So for the brake calipers, the standard part will also be used for this component in the braking system, which is Zakis Willwood GP200, which is also used by Mora. So in the journals by Mora, the operating maximum pressure for this component may go up to 5,000 psi, which is around 34.47 megapascal, and 1,200 and to 1,200 psi, which is around 8.274 megapascal. So the normal operating pressure that was given by the manufacturer states that 1,200 psi should not be the normal operating temperature, the normal operating pressure. However, the study by Mora mentioned that the ratings claim by applying a causal fatigue cycle, which does not reflect the ultimate maximum pressure of the component. So what Mora did is he did a destructive test, and the results have shown otherwise, which the ultimate maximum pressure can go up to 5,000, and the normal operating pressure is actually 1,200 psi. Other than that, the reason why this brake calipers are chosen is because it's lightweight and it's very low cost, considering that it is a high performance brake caliper. Moving on is the material for the brake rotor. So the design for the brake rotor was already made by the UITM Motorsports team. So we will only be discussing about what kind of materials to be used. So material to be chosen for this component is 4130 steel alloy. Um, it is also used by Mora and is also will be tested on a dynamometer test rig. So this material was chosen because it is able to withstand high temperature ranging from 500 to 800 degrees Celsius. So in addition, this material does not change drastically upon change of temperature over time during loading and has a longer life cycle compared to other materials under the same subjected to the same loading. So this is the literature review. Moving on to the problem statement objectives. So the problem statement objectives has to follow the Formula SAE rules and regulations. So the so here are the guidelines that are outlined in the Formula SAE rules and regulations. So first of all, the braking system should be able to be locking on all four wheels, and it needs to be independently operated, meaning that each master there will be two master cylinders, each have their own reservoir. So in case of one to the front and one to the rear, so in case of either one or the front or rear back is failing, um, either or will still be able to operate and give effective minimum braking power requirement to stop the car. So other than that, other than their own master cylinder, other their own reservoir for their own master cylinder, you can also put an OEM style reservoir. So this is to ensure that they can get the minimum braking force required. So the braking system main components must be protected with scatter shields in case of collisions. This is to ensure the safety of the driver and the functionality of the system. So the minimum braking force for in the rules and regulations is 2,000 Newton, and also the brake pedal should be machined from steel, aluminum, or titanium, or fabricated by steel or aluminum. And the braking system must not fail even when the non-load bearings are failing. So this should not interfere with the system, even though it has nothing to do with the main component of the system. So in conclusion, selecting the right material and dimension based on analysis are only the beginning of this actual implementation. So testing on the site and real life application may be different based on surface, temperature, weather conditions, configuration, setups, and maybe errors that we tend to overlook that could contribute to the failures of this design. So therefore, further research should be advised to achieve better result of braking design and materials to be used. Moving on is the literature reference that I have mentioned just now by Koshikwa, Shaitlin, Mora, Patel, and Duff. Next is the methodology of this project. So we separated methodology into two parts. The first one is the project flow, and the second one is how we did the brake test theoretically speaking. So this project. So firstly, we will talk about the project flow. This project flow has been divided into 8 stages. So we will only be discussing to the fourth stage for this presentation. And this project timeline is monitored through a Gantt chart, which we will make sure that it is on schedule and will finish on time. So firstly, we have identified the problems and objectives of this project. As we discussed earlier, it is the problems and objectives are according to the FSAE regulations and also improving the existing design. And secondly is review the published and endorsed journals of articles for concrete evidence to follow the right procedures to design the braking system. And the next one is the set the parameters needed and limitations is the feasibility that could be cost and time. So desired parameters could also be an indicator like the desired speed, the desired braking distance, desired braking time could also be the parameters that we can set. Cost could also be a limitation. Moving over is the design and analysis is to ensure that the design is safe and reliable. This will be explained more briefly in the next slide. Next one is we have fabricate, set up, and test the design. And then we have the record, the test, and document for future improvement. Then amend and improve design based on current feasibility like time and money. And lastly is finalize the design. So moving on to the brake test. So this brake test is inspired by Mora, which he did to determine the right material for the brake rotor. So this test is conducted using a dynamometer test rig. So the dynamometer test rig functions as a as a device to measure the torque and rotational speed of an engine, motor, or any prime mover. So by installing the engine and putting an adapter for the engine for the brake, along with the brake calipers on the brake rotor, thermal analysis can be measured by using the sensors. So here are the steps that we will discuss on how to determine the right material. So firstly, we will install the calipers to the brake rotors along with the sensors that I mentioned just now. And then we run the dyno at 1250 RPM or 80 kilometers per hour, and then apply the braking operation, observe the temperature and pressure on the piston and the brake. So when apply the braking, when the temperature reaches up to 500 degrees Celsius, you detach the brake and let the rotor run for cooling, and then repeat by observing the temperature and increase by 100 degrees Celsius until 800 degrees Celsius. And so um, here, when the rotor hits 500 degrees Celsius, detach the braking operation and let it cool down. So repeat the process, like I mentioned just now, by applying the brake to achieve an increasing test until 800 degrees Celsius. Then repeat the test at least 5 times to average the data and save the results. And so that's how the brake test will be done. So next we will talk about the expected results. So here are the known parameters for the theoretical calculation. So the ultimate tensile strength and the yield tensile strength is for the brake rotor. So we start out by using the known Taylor ratio, which is 5. Then using the average mass of the driver, which is 80 kilograms, you multiply with the mechanical advantage and you will get the output mass of 400 kilograms. Then from the piston diameter of the master cylinder, we can get the area of the master cylinder. And then from the output mass, you can get the force by assuming that the brake pedal will be pushed downwards, which is gravity. Then we'll get the force exerted on the master cylinder. Then using the formula pressure to force over area, we can get the pressure on the master cylinder. Then from the pressure at the brake calipers, the pressure is still the same, flowing through the brake circuits to the brake calipers, but the force may differ due to the difference in area. So the area that we can get the force exerted on the brake calipers, which is 6054.16 newtons. Um, so from the force, we can get the pressure induced by the driver upon braking, which is 7.744 just now. So since it is lesser than 8.274, which is the normal operating pressure, the brake can withstand higher input force from the driver in case of emergency and is safe to use. And then moving on, by assuming the geometry of the car as shown in the diagram, we can use the moment at the front wheel and the rear wheel. We can get this equation. So from this equation, we can get the normal force on the front, which is 2041.06 Newton, and to the rear is 411.44 Newton with a ratio of 4.96 to 1. So if we divide both the front and rear tires by 2, we can get each individual force required for both front and rear tires to stop the car. So based on the force obtained from the force calculated at the calipers, the force is exerted higher, the force exerted is higher than the force required, though so it is safe to use. So in addition, since the pressure calculated is lesser than the ultimate tensile strength, like previously, thus the pressure induced is safe for the brakes, for the brake rotor. So using the time and velocity formula, we can also obtain the time taken for the car to decelerate to stop, which is around 3.6 seconds. So here are the analysis for the brake rotor. As you can see, the red part is where the friction will induce. So that is where the wear will happen, which is on up to 800 degrees Celsius, which we mentioned just now for the brake test at the dynamometer test rig. And the next one on the right is the brake pedal analysis. Force input of 400 kilograms or 80 kilograms at the brake pedal ratio it is at the brake pedal is sufficient to sustain, since it is also be manufactured either steel, aluminium, or titanium and whatnot. And next one is the analysis on the piston. Since we mentioned just now that the pressure induced is 7.744, which is less than the normal operating pressure, that means the piston can withstand the pressure induced. So this is my presentation of my FYP. Hope you all understand my presentation. Thank you very much and have a nice day.